Welcome to Arise Online Chemistry class. Today we are going to discuss the MCQs of Thermodynamics chapter. So let us move on to the first question. Out of the following, identify the intensive properties. We know that thermodynamic properties are classified into two types, intensive and extensive properties. Intensive properties means those properties which does not depend on the amount of substance, and extensive properties, those properties depends on the amount of substance. So in the question, out of the following, identify the intensive property. Intensive property means those does not depend on the amount of substance. So let us look into the option: enthalpy, temperature, then option B volume, option C enthalpy and volume, option D temperature and reflection coefficient. Option A, in enthalpy and temperature, enthalpy is an extensive property, temperature is an intensive property. So they have to identify which is both are intensive properties. So option A cannot be the answer. Now option B volume, volume depends on the amount of substance. So that is an extensive property. Then option C enthalpy and volume both are extensive, and option D obviously that will be the answer, right? That is temperature and reflection coefficient. So temperature and reflection coefficient are those substance does not depend on the amount of substance. So it is option D. So, and there is also one more point we have to discuss here. The ratio of two extensive properties will be intensive. For example, we know that mass, volume both are extensive, and we know that mass by volume is equal to density, and density is intensive in nature. So the ratio of two extensive will be intensive in nature. So what are intensive properties? Those properties does not depend on the amount of substance. Now moving on to the next question. Correct relation for adiabatic process is. Adiabatic process means there is no heat exchange. That is known as adiabatic process. So adiabatic process is Q is equal to K plus W. That is option D. Now moving on to the third question. When a gas is compressed adiabatically and reversibly, the final temperature is. What is an adiabatic process? In adiabatic process, there is no heat exchange. Or we can say Q is equal to 0 for adiabatic process. So for Q to remains constant, the heat should not be transferred to the surroundings from the system. So the only way to make Q constant is that to increase the temperature. So in an adiabatic process, we know that heat remains constant. There is no heat exchange between the system and surroundings. So in order to make the Q remains constant, we cannot supply the heat from system to surroundings. So, and to make the Q constant, there is only way to make Q constant is that to increase the temperature. So, what is the option? When a gas is compressed adiabatically and reversibly, the final temperature will be higher than the initial temperature. So, which is the option? It is option A. Now moving on to the next question. Which one is a state function? So what is a state function? So the properties which depends only on the initial state and final state are known as state function, and those properties depends on the path followed are known as path function. So let us consider which all are state functions. Next is, which one is a state function? Heat supplied at constant pressure, that is QP is equal to delta H. Then heat supplied at constant volume, QV is equal to delta U, and enthalpy is H delta H. So which is state function? All are state function. Internal energy, that is delta U, delta H enthalpy, all are state functions. Example for path functions are work and heat are examples for path functions. So they are asked about which one is a state function. All the above are state functions. So which is the option? It is option D. Now moving on to the next question. Q is equal to minus W is not true for. So let us consider which are the options. Isothermal process, adiabatic process, cyclic process, option D 1 and 3 both. So which is not true. So it is not true for A and C. For isothermal process, Q is not equal to minus W. For adiabatic process, Q is equal to what? 0. And for cyclic process means what? The initial state and final state is the same, and option D 1 and 3 both. It is actually 1 and 3 both. That is for isothermal and adiabatic. So it is option D. Now next question, enthalpy of 1 mole monoatomic ideal gas, that is very easy, that is equal to 5/2 RT. It is option B. Now moving on to the next question. If work done by the system is 300 joule when 100 calories of heat is supplied to it, then change in internal energy during the process. This is a question which is related to first law of thermodynamics. What is first law of thermodynamics? Energy can neither be created nor be destroyed. It can be only converted from one form to another. That is known as law of conservation of energy, or otherwise known as first law of thermodynamics. So what is the mathematical expression for first law of thermodynamics? Delta U is equal to Q plus W. So delta U is equal to Q plus W. So this is the equation for first law of thermodynamics. They are asked to calculate the change in internal energy. So what are the information given? If it is work done by the system is 300 joules. So work is given as 300 joule. Since it is work done by the system, it is minus. When 100 calories of heat is supplied to it. So we are giving heat to the system. So Q will be positive and Q is equal to 100 calories. But we cannot directly substitute it because both are in two different units and the option is in joules. So we have to convert that calorie into joule, and we know 1 calorie is equal to 4.184 joules. So what will be 100 calorie? 100 calories is equal to 4.184 into 100 joules, that is equal to 418.4 joules. So now we have converted this Q, which is in calorie, into joules. Now we can substitute in the equation delta U is equal to Q plus W. So let us substitute it. Delta U is equal to Q plus W. Q is equal to 418.4. Work is negative. Why work we are giving negative? Because work is done by the system, that is negative. Work done on the system, it is positive. So it is minus 300. It will be around 118 something. So this can be approximated as 120 joules. So which is the option? It is option T. Now moving on to the next question. A system has internal energy equal to E1, that is the initial internal energy. Here internal energy is represented by the symbol E, not U. You can also use the symbol E for internal energy. So what is internal energy? Actually it is the sum of all the energies associated with the system is known as internal energy. So in initial internal energy is given as E1. For 50 joules of heat is taken out of it and 600 joules of work is done on it. The final energy of the system will be, that is a question. So here Q is given as what? 450 joules and work is given as 600 joules. They are asked to find out the final energy of the system. So they are asked to find out E2. So we know that delta U is equal to what? Q plus W. What is delta U? Final internal energy minus initial internal energy, that is known as change in internal energy. So delta U can be represented as E2 minus E1 is equal to Q plus W. What is Q? 450. What is work? That is 600. So in total of 1050. So they are asked what it is, E2. So what will be E2? E2 will be is equal to 1050 plus E1. So which is the answer? It is option B. Now moving on to the next question. Identify the state function among the following. That is the next question. So state function, example, state function means those properties depends only on the initial and final state are known as state functions. And Q is an example for a path function. Path function means those properties depends on the path followed. Q into W, Q by W. What is Q plus W? Change in internal energy. Q plus W is equal to delta U, that is change in internal energy. So change in internal energy or internal energy is an example for a state function. So which is the state function? It is option D, which is internal energy change. That is option D. Now we can move on to the next question. The difference between the heats of reaction at constant pressure and constant volume for the reaction 2C6H6 in liquid state plus 15 O2 in gaseous state giving 12 CO2 in gaseous state plus 6 H2O in liquid state at 25 degrees Celsius in kilojoules. We have to get the answer in kilojoules. So the difference between the heats of reaction at constant pressure and constant volume. So let us consider what is heat of reaction at constant pressure and heat of reaction at constant volume. So heat of reaction can be considered as enthalpy of reaction. Heat of reaction at constant volume is equal to, we can be represented as QV, which is equal to delta U, and heat of reaction at constant pressure, that is QP, which is equal to delta H. So what they have to find out, the difference between the heats of reaction at constant pressure and constant volume. That is, they are asked to find out QP minus QV, which can be written as what? Delta H minus delta U. They are asked to find out the difference between delta H minus delta U, or change in enthalpy minus change in internal energy. That is what we have to find out. And what is the relation between delta H and delta U? There are two equations we can use. Delta H is equal to delta U plus P delta V, or you can use delta H is equal to delta U plus delta NGRT. For solids and liquids, there is no much change in volume. So P delta V will be 0 and delta H will be equal to delta U for solids and liquids. Delta H and delta U will be the same. But for reactions involving gaseous reactants and products, volume should be taken into consideration. So the equation is delta H is equal to delta U plus delta NGRT. So that is the equation that we have to take into consideration. So let us consider. So the equation is delta H is equal to delta U plus delta NGRT. So let us consider. They are asked to find out delta H minus delta U, that is equal to delta NGRT. So what is delta Ng? It is the number of moles of gaseous product minus number of moles of gaseous reactant. So delta Ng is equal to number of moles of gaseous product minus number of moles of gaseous reactant. So let us consider. So in reactant side, benzene C6H6 is in the liquid state, so we don't have to consider. 15 O2, that is in the gaseous state. In the product side, you have carbon dioxide in the gaseous state, water is in the liquid state. So number of moles of gaseous product minus number of moles of gaseous reactant means 12 minus 15. So that is equal to 12 minus 15, that is equal to minus 3. So delta H is equal to, delta H minus delta U is equal to minus 3 into, what is the R value? R is universal gas constant. R is equal to 8.314 joule per Kelvin per mole, and since we require the answer in kilojoules, you have to multiply with 10 raised to minus 3 in order to make it into kilojoules. So it is 8.314 into 10 raised to minus 3. Here the temperature is given as 25 degrees Celsius. So, degrees Celsius is equal to 298 Kelvin. So 25 degrees Celsius is equal to 298 Kelvin. For easy calculation, I am approximating around as 300 Kelvin. Why? In order for easy calculation, into 300. Okay. So what will be the answer? So minus 3 into 8.314 into 10 raised to minus 3 into 3 into 100. 10 raised to minus 3 into 100 is 10 raised to minus 1, right? Minus 3 into 3, 9 into 8.314. What is 9 8s are? 9 8s are 72. So 72 into 10 raised to minus 1 means minus 7.2. So let us consider the options: plus 7.43, plus 3.72, minus 7.43, minus 3.72. So we got it as minus 7.2. Why we got it as minus 7.2? Because we approximated it as 300. So what will be the answer? Minus 7.43. That is option C. So for entrance, we can do these kinds of approximation. We know that actual temperature is 298, but the multiplication with 298 is much lengthy. So what we do is, we approximated that 298 to a neighboring whole number, which can be easily calculated. So 298 is approximated to 300. So the calculation becomes very easy. So by considering that approximation, the answer will be minus 7.43 kilojoules. So it is option C. Now we can move on to the next question. For a gaseous reaction, A gas plus 3B gas giving 3C in gaseous state plus 3D in gaseous state, all the reactants and products are in the gaseous state. Now delta E is actually delta U, okay, is 17 kilocalories. Here it is given in kilocalories at 27 degrees Celsius, assuming R is equal to 2 calorie per Kelvin per mole. The value of delta H for the above reaction. Here also it is a relation between what? Delta H and change in internal energy. So delta E can be represented as delta U. So what is the equation? The same equation what we used in the previous question. So delta H is equal to delta U plus delta Ng RT. Okay. So here we can do it. We are asked to find out delta H. So I am substituting delta U in kilocalories itself, that is 17 kilocalories. What is delta Ng? It is number of moles of gaseous products minus number of moles of gaseous reactant. So delta Ng is equal to number of moles of gaseous products, 3 plus 3, that is 6, minus 3 plus 1, that is 4. So 6 minus 4 is equal to minus 2. So delta Ng is equal to 6 minus 4, that is equal to minus 2. So minus 2 into R. R it is given in calories, but change in internal energy, delta U is given in kilocalories. So we have to convert this calorie into kilocalorie. How? By multiplying with 10 raised to minus 3. So 2 into 10 raised to minus 3 into 27 degrees Celsius. So 27 degrees Celsius is equal to 27 plus 273, that is equal to 300 Kelvin. So into 300 Kelvin. So delta H is equal to 17 minus 2 into 10 raised to minus 3 into 300. So this is the substitution that we require. So what I am doing is 10 raised to minus 3, and out of this 300 there is 100. When you multiply the 10 raised to minus 3 with that 100, it becomes what? 10 raised to minus 1. So it is 17 minus 4 into 3 into 10 raised to minus 1. 4 3s are 12 into 10 raised to minus 1, it is 1.2. So 17 minus 1.2. So what will be 17 minus 1.2? It will be 15.8. So which is the option? 15.8 kilocalories, that is option A. Now moving on to the next question. For the reaction Ag2O solid giving 2 Ag solid plus half O2, which one of the following is true? So this is also a reaction which is involving gaseous product. There is no gaseous reactant here. So the same equation we have to use here. What is the equation? Delta H is equal to delta U plus delta Ng RT. So it is based on the value of delta Ng. If delta Ng is equal to 0, this delta Ng RT part becomes 0, right? So in that situation, delta H will be equal to delta U. That is the first situation. Now the second situation, delta Ng is negative. Delta Ng is negative means what? Delta H is equal to delta U minus something. So what will be the situation of delta H? Delta H will be less than delta U, right? Delta H will be less than delta U. So we are subtracting delta H is equal to, we are subtracting delta U from something. So delta U will be a greater value when we consider with what? Delta H. Then delta Ng is positive. Delta Ng is positive means we are adding something to delta U, right, in order to get delta H. So delta H is greater than delta U. So delta H is greater than delta U. So these are the three situations we have to consider when we consider the reactions involving what? Gaseous reactants or products. If delta Ng is equal to 0, then delta H is equal to delta U. Delta Ng is negative, then delta H is less than delta U. If delta Ng is positive, then delta H is greater than delta U. Okay. So let us consider in this case, for the reaction Ag2O solid giving 2 Ag solid plus half O2. So what is delta Ng? Number of moles of gaseous product minus number of moles of gaseous product minus number of moles of gaseous reactant. So there is no number, how many number of moles of gaseous product? There is only half moles of oxygen, that is 1/2 minus, is there any number of moles of gaseous reactant? There is no number of moles of gaseous reactants, so it is 0, so that is half. So what is delta Ng here? Delta Ng is positive. If delta Ng is positive, what is the situation? Delta H is greater than delta U. So delta H is greater than delta U means delta H is greater than delta E, because here we are using E as a representation for internal energy. That is the only difference. Either you can use U or you can use E for representing internal energy. So if delta Ng is positive, delta H is greater than delta U. So in this option it will delta H greater than delta E. So it is option D. Now we can move on to the next question. That is, for a reversible isothermal expansion of 1 mole of an ideal gas at 300 Kelvin from a volume of 10 dm cube to 20 dm cube, delta H is equal to. So for an isothermal reversible expansion, what do you mean by isothermal reversible expansion? Isothermal reversible expansion means that is temperature remains constant during the process. For 1 mole of an ideal gas at 300 Kelvin from a volume of 10 dm cube to 20 dm cube, they are asked to find out enthalpy change. Since temperature remains constant, there is no change in enthalpy. Enthalpy remains constant, that is delta H is equal to 0. So which is the option? It is option D. I hope till now you have all understand, and thank you.